Right. I guess all of you can hear me clearly. And good evening to everyone. As I mentioned you last day, so I would like to make these presentations a little bit more interactive rather than just giving you, the lecture for the whole hour. For that, I am using a different software, and assuming that all of you have at least a mobile phone with you, please join with my presentation so that it will be more interactive for you as well. Join with my presentation using this particular web address, which called joinpd.com. And once you go into that address, you will be asked for a code, and that code is right here from white color, that is IYRFVB. And what will happen is actually when you log into the web, you will directly see my PowerPoint presentation in your smartphone or in your laptop or whatever device that you are using, right? So just try it. So I will give you like a few minutes, and I will be seeing when once you are connected, how many of you are connected here, right? So this is just to make it more interactive for you. And also I will be asking like, few questions here and there so that you can anonymously answer for those questions as well. So in that way, I can understand whether you understood the content in the presentation and the concepts that I am trying to teach you, right? So this is just to make sure that, so please try that from your mobile phones, right? So you will also see my presentation on your mobile phone on the screen so that you don't have to worry whether I can see whether you can see my presentation or not. So please try that. And if you need the link, let me just type joinpd.com. So that is what you have to type. So once you type, then you will be asked for a small code, and that code will be simple IYR space FVB. And I can see one of you already connected, and this is the code. So once you enter this code, you will be directly go into my presentation from your smartphone or whatever device that you are using, right? So one is connected. So please, others, please try as well. So this is where I told you that it may be not enough for just to go and watch the recordings, because I will be doing this in a more interactive way by asking few questions, and those answers for those questions will display in your mobile phone, right? Sometimes these may be multiple choice questions most of the time. So you will see the question, and also you will have a small button or link on the side of your mobile phone asking like to show the answers, and you can click the answer, right? So then once all of you get answers, we can see the percentage of answers and discuss the solution, right? So in that way, it will be more easier for you to understand the concepts and the lessons, right? So that's what I am trying to do here. And now I can see that already 5 of you have connected. So I will, since today is the first day, so I will wait for like 1 or 2 minutes for you to connect. So try to connect to the class. Also for your friends who are, if they are planning just to watch recorded videos, just let them know that we are doing this in an interactive way. So just watching the recorded video may not be enough for them, right? So they have to join for the class. And at the same time, I will actually post the recorded video, but that recorded video is just in case if one of you maybe missed the class due to a technical failure of a smartphone or with technical failure with the connection, something like that, right? So I can see 10 of you are connected, 11 connected. So let me just wait another 1 or 2 minutes. Right, so since it takes time, let me start the class. Even though I start the class, you can still join the class with the code, and that code is displayed on top right-hand corner of my screen as well, and it is also in the chat window. And to make it easier for your questions, let me switch off my video for now. And so let's start the presentation, and I would assume that all of you can see my screen, right? So I have shared my presentation in a web browser, and I assume that all of you can see it. So if not, please let me know, right? And, so this is the first presentation that we did last Friday or Wednesday, I guess. And this is where we stopped. So we have been talking about the consequence of the light traveling time. So what is the consequence due to the time it takes for light beam to travel from one place to another place? And this is very significant in astronomy because of the enormous distances that are involved. And we have been discussed what happens when a particular object or a star is like 500 light years away, like that. And we have mentioned that astronomers build these very large telescopes so that we can collect more and more faint light in the universe, right? So this will allow us to look at more deeper and more fainter objects, right? So that's the whole idea of building up these larger telescopes. And right now, this is one example for such large telescope. On the right-hand side, what you can see is the Hubble Space Telescope, which is considered as one of the like a prominent telescope in the field of astronomy, which did a great service for like, let's say up to last 30 years. The data that we gathered from this telescope actually change our way of looking at the universe and our thinking pattern of the universe as well. So we have, I think, understand lots of things about our universe thanks to this Hubble Space Telescope. It's still there, but now there are new telescopes coming out. And another example is this very large telescope or VLT telescope in the Chile, which is again a very large telescope that help us to understand the universe by detecting very faint objects that are so far away, right? Now, we will actually talk, there will be a separate section about the telescope. We will talk about, the basic technology behind telescopes and different types of telescopes under that particular topic. But this is just an introduction. And right. So I would like you to answer this question. The most powerful telescope currently in the space is, and there will be 3 answers that is displayed in your smartphone if you are using it, and just tap one of the answers. I mean, just this is actually not something that I am going to grade for you, right? So this is just for me to get an idea about what kind of things that you know and what kind of things that you don't know, so that I can rearrange my lectures accordingly. And also you will get a good idea what kind of things that you already know, right? And also you will get a good idea like what kind of things that you should know as well. And this is just a very general and basic, general knowledge question that I have asked here. So try to respond to this one. I can see that 3 of you have responded and only 18 of you have actually logged into this one. So next time or still today you have time, make sure that you log into this and try to respond to these questions, right? Because this is the only way that I can interact with you to make sure that you are following what I am teaching here, right? So I have 5 responses. So how about the others? So just try to have your response, then I will display the answers here. And at the same time, please let me know if you have any technical difficulties like following the presentations and logging into these this particular setup, right? Right, so there are 8 responses out of 38. Right, since this is a basic question, let me open up the answers now. You can still respond to the question, and the question is it's a kind of a general knowledge question. The most powerful telescope currently in space is, and I have given you like 3 responses to select right here. And I can see 4 of you have answered A and 5 of you have answered B, right? So 1 you have answered C. So let's see, it's keep counting. So you can see that, so your votes are counting here. Now I can see that some of you have changed your mind and put the answer into B. So some of you have mentioned that the first one is actually the Hubble Space Telescope. So 4 of you are telling that Hubble Space Telescope. And by the way, you are very free to give any kind of answer, right? So the answers are kind of anonymous, that I do not know who is giving which answer, right? So that is not relevant to me at this point. So I just need to make sure that you are interacting with these lectures. Right, so 15 of you have answered. So I can see that most of you have selected the second option, that is James Webb Space Telescope. And the first one is the Hubble Space Telescope. And the third one is Spitzer Space Telescope. And of course, you can rule out the Spitzer Space Telescope because it's a very small and not that much powerful telescope in the space compared to the James Webb and the Hubble Space Telescope, right? Now, for those who have given the answer as the Hubble Space Telescope, it's a very fair answer, but it is not the most correct answer according to the up-to-date information that we have, or up-to-date technologies we have, right? So actually, the correct answer is James Webb Space Telescope, right? Which is the answer B. And if you go to the news and Google it, you will see all the news that came out about the James Webb Space Telescope very recently. It's a very powerful telescope, and so we consider that as the most powerful telescope that we have sent to the space ever, right? And compared to the James Webb Hubble Space Telescope seems to be a very small telescope, right? And the technology and the way it is deployed, and how it is unfolded, and the technology behind this large 6.5 mirror in the James Webb Telescope, everything is like high-end clearest technology that they are using, right, for the first time, right? So that is why James Webb is very one of the most important equipment that we have ever sent to the space, and we are still at the setting up time for the James Webb Telescope, because it has to go and go into the space and has to be stabilized there, and that will start taking data probably starting very soon. And once these data coming from the James Webb, I think we will have like answers to a lot of mysteries that we don't know now, right? So that's how it works. And right, so I appreciate and thank you for all of your responses who have responded. I can see that most of you have responded. So I'm going to look the responses now, and we'll move on to the next question. Sorry, next slide. Right, so that's the first part that I have been talking up to now is very basic things like units that we are using in the astronomy and why those units are important and what is light year and why we are using light years and why we need telescopes, those kind of very basic stuff, right? And I'm continuing with that introductory part. So I'm going to take you with a brief tour of the universe. And this is just to give you an idea what kind of things that we are going to talk in this particular lecture series. And if we go a tour in the universe, what kind of things that we can observe, right? Of course, we can go and touch, we cannot go and touch them, but we can observe most of these things through telescopes. Now, we are going to start from our own Earth, and this is an image of the Earth. So that is the humanity's home base. And what you see here is the Western hemisphere of our Earth viewed from space. And this image is taken like from 35,400 kilometers away from the Earth, right? Or above the Earth. And the data has combined from several satellites to create this image. And we will start our tour for the universe from our own Earth where we live, right? Now let's go into the next step and see what we can see after that. Now this image right here, you should see that you can see that in this image right here on the left-hand side, I have the Earth, and there is a tiny little object on the right-hand side, on the right-hand corner. So that is our moon, right? So the image is constructed in this way just to give you an idea about the scale of Earth and moon for both the size and the distance, right? So in that way, you will remember it very well, and you can see that in terms of the time it will take, in terms of the time it will take for a light wave or any kind of radio wave to reach from moon to Earth, it will take 1.3 seconds, right? So what that means is if you go outside and look at the moon right now, what you see is how the moon looks like 1.3 seconds ago, right? And this is the closest object that we have. We used to say that our nearest astronomical neighbor for our Earth, that is moon, right? And you can see from the scale that Earth is actually larger, very clearly Earth is larger compared to the moon. So that will be our next object in this space if you are going a tour, right? So everybody knows what this picture is about. Next, what we have is after moon, we have our own solar system, right? Now you can see on the left-hand side right here, I have the sun, and actually only a tiny part of the sun is displayed here because the image try to scale to show up different sizes of these planets. And then we have the Mercury very close by, and then Venus, Earth, this is where we live, and then Mars, and Jupiter, Saturn, Uranus, and Neptune. And these are the main planets in our solar system, in our neighborhood. And then apart from that, we have a few dwarf planets, which are, you can see, relatively smaller than the usual planets. So the Pluto, then you have Make, Aries, those kind of dwarf planets, right? So the dwarf planets differ from the planets in our solar system because they are smaller in terms of the size, and there is a different definition put up by the International Astronomical Union to define dwarf planets and differentiate between dwarf planets and planets in our solar system. And you can see that the Pluto was the planet when I was learning astronomy, but due to this new definition for planets, Pluto has also become a dwarf planet now. Now we have only 8 planets in our solar system. And one thing you can get from this image is the size of the sun compared to the other planets, right? You can see the sun is, in terms of the size, the sun is very huge. And then the Jupiter and Saturn is very large planets compared to all the other planets in the solar system as well. Right. So this is again another question for you. How many stars we have within our solar system? And this is again, you have to put a number, right? So you just read the question, and on your screen there is a button that you can click and answer. Just put a number, right? So you can enter the number, and we will once you have the numbers, we will look at the responses, right? How many stars we have within our solar system? Just have a guess from the general knowledge. These things I have not taught you in this course. So these are just general questions that will be interesting for you to know as students who did astronomy, right? So I would like you to answer for these basic questions and then get the answers and discuss. So I will probably give you like 1 or 2 minutes to have an answer for this particular question. So 7 of you have responded, and I can see 43 of you are on Zoom and 31 has logged in online with interactive slides. So all of you can answer. I mean, once again, remember these answers are anonymous, right? So it's better that you put your answer because nobody knows who answered here. But the advantage for me is I can kind of get an idea about whether you have understood the questions that I am asking and also what's going on here. Now, when it comes to the next day, when I prepare the slides, so those questions, most of the time, they will come from what we are learning, right, in the class. So based on what you have learned, I'm going to ask questions like this so that you can answer, right? So in that way, I will get an idea that you have understood what I am teaching, right? And also you will learn at the same time, right? So I have almost 13 responses. So let's see how the answers looks like. I can see that statistically, most of you have put like 1, and then 1 of you have put 100, like very interesting. And you can see that when you are putting down these the answers, so I can see the statistical responses, how you have responded, right? So that is 2. Right now, you can see that clearly from these answers that most of you have selected 1 right here, right? And of course, one selected 0 and he changed it to maybe 1. And then you have, some of you have, few of you have actually, probably 1 or 2 have selected like 7, more than 7.5, and then 1 of you tell like around maybe 8. Actually, when you look at our own solar system, we have only 1 star, right? So that is, which is that star? So that is our sun, right? Sun is the only star in our solar system. There are no other stars in the solar system, right? So we have the sun and the planets around it. So that is the solar system, right? So I just need to, make it aware, because sometimes students get confused when somebody asks from you about these very, basic questions. So it is just, there will be one only one star in our solar system, that is our own sun, right? So that's how it works. So those kind of questions, you will never forget this answer when you look at something and answer the questions in an interactive way like this. Right? So remember that we have our sun in the solar system. So that is the only star that we have is the sun. So only one star, and that is sun, right? Right. So let me thank you for everyone who actually answered, and I'm going to lock the question and go into the next slide. Right. So that's about. So we started from the Earth and moved on to the moon, which is the nearest neighbor, and then went on to talk about the sun and the solar system. Now, let's go into the next step. Now, when you look up the sky on a clear night, so there will be a large number of stars filled in the sky, right? And believe me that all these stars that is visible to your unaided eye are actually part of a single collection of stars. And we call this as the Milky Way galaxy, or simply the galaxy, right? Now, this is something very interesting. Actually, I should have asked you about this as a question as well, which I couldn't. So when you look at, when you just go, if you go just outside and look at the sky, you will see huge number of stars, right, on the sky. Now, if you think about all these stars, actually almost all these stars actually all these stars belong to our own Milky Way, right? Milky Way is our galaxy. The name given for our galaxy is Milky Way, right? Now, since we are inside the Milky Way, what we see is actually a dark, we just see only the disk, right? So disk, so excuse me, we will only see this kind of pattern as the Milky Way. If you look at this top left-hand corner picture, if you go outside and look at the sky, this is what you would see as the Milky Way, right? And now, if you think about our own sun is actually one of these hundreds of billions of stars inside our Milky Way. So remember that initially the question that I had for you, we have only one star in our solar system, so that is sun. But if you look at the complete, or if you take the complete Milky Way, we have billions of stars inside that, right? Which looks like our own sun. Inside our galaxy, there are billions of stars, right? Now, just to make it, just to make it a little bit clear, think about within a sphere of 10 light years in radius centered on the sun. So let's assume that you are on the center, which means you are on the sun. And then if you look at 10 light years circle from the sun, you will find roughly around 10 stars. So the number of stars will be very low, right? But if you go into a sphere covered by 100 light years in terms of the radius, then you will have roughly around 10,000 stars, right? So that's how this number of stars grow up, right? Now, if you go for around 1,000 light years sphere, then you will find around 10 million stars, which belongs to our own Milky Way, right? Actually, even if you go up to 10,000 light years sphere, you are still inside the Milky Way, right? Now, the Milky Way is considered as a galaxy which belongs to this spiral type. So, you know, when we talk about the galaxies, we will learn that there are different types of galaxies that we use to classify. The two main types are elliptical galaxies, which have this elliptical shape, and spiral galaxies, which is the galaxies that have spiral arms. Right now, our own galaxy is a spiral galaxy. However, we cannot see the complete shape of our galaxy because we are inside the galaxy, right? So this is like when you are inside something, you cannot get a complete idea about the shape of that particular object, right? However, if you go into this image in the lower left-hand corner, this image right here, this is again a galaxy named NGC 1073, which is again a spiral galaxy with clear spiral arms, as you see here. And this is very similar to our own Milky Way galaxy, right? So since we cannot get a picture of our own galaxy, since we are inside it, we can think of a galaxy like this, NGC 1073, and get an idea about our own galaxy, because our own galaxy is very similar to this particular galaxy, which is a spiral galaxy, right? Now, since that, just keep in mind that we start from our own Earth, and then we looked at the moon, which is the nearest neighbor, and then we are looking at our solar system with all the planets and dwarf planets. Now we have looked at our own galaxy, right? So that is the next next object that we will meet. And then another thing that we have inside these galaxies, now I told you that there are large number of stars in our galaxy, right? However, not all the stars live by themselves as the sun does. So we all know that sun is an isolated star. So there are no other stars close to the sun, right? So that's why we told that the sun is the only star in our solar system. However, when these stars born, many of these stars born as doubles or triple systems. So which means there are two stars together or maybe three stars together, right? So when there are two stars together, we used to tell that it is a double star, right? In a number of places, if you look at even inside the Milky Way, there are large number of stars that have formed together, right? And they actually, these stars that form together, so they are placed, they are located as star clusters, which means large number of stars are together in a certain location. And these type of locations we used to tell as star clusters. And star clusters are actually something that we have to study separately, because when you take star clusters, there are two main types, globular and open star clusters. And then we can look at the properties of the star clusters differently, but we will talk about that as well in a different section. But for now, just keep in mind that these stars that you see on the sky, some of them are actually, most of these stars come as double stars or triple stars, and even as star clusters, which means large number of stars kept together, right? So one good example for a famous star cluster is actually Pleiades, right? And this is also used to call as seven sisters, right? I think in these days you cannot see the Pleiades star cluster, but in a day around like February, March, this Pleiades star cluster is clearly visible and it is up in the sky. Right now, since it is May and June, I think it should not be that much visible now. That is one example for an open star cluster, right? Now, the star cluster that you see here in the right-hand side is called M9. That's the catalog number given to this particular star and this star cluster. And this star cluster has around 250,000 stars, right? And this image is taken from the Hubble Space Telescope. And remember that you cannot see all these stars from the naked eye. And this is the magic that the Hubble could do, right? So it has this ability to take these nice pictures of different objects on the space. So inside the Milky Way, Now we have our solar system, and maybe there are other solar systems, and we have stars, and the stars come as double stars, triple stars, and sometimes as star clusters, right? So that is what we can see inside the Milky Way. Now, let's look at even more larger scale in the universe, right? Now, this is, so I'm taking this picture to explain you how the universe looks like outside the Milky Way, right? Now, this is an image taken from I would say this is from the Atacama deserts in Chile. And what you see in this background is this large number of disks is actually a different telescope. We used to tell this as the ALMA, or Atacama Large Millimeter Submillimeter Array. And this is a different kind of telescope, which I will explain to you when we are talking about telescopes in future lectures. And what I want you to notice here is these two regions, right? Here, there is a small white patch, and there is another patch, kind of, cloudy patch on the sky. And this is a real image taken from this desert. And you can see when the light pollution is less, you can see a lot of wonderful things on the sky, right? And this is from the southern part of from the southern hemisphere. And these two are actually two small galaxies, right? One is called Large Magellanic Cloud, and the other one is called Small Magellanic Cloud. Two galaxies that you can see from the southern hemisphere, right? And these are two galaxies which are outside our Milky Way, right? So this is one of the nice pictures that I can explain that there are other galaxies outside our Milky Way, right? And here is another galaxy, which is the closest bright spiral galaxy for us. And this is called Andromeda galaxy. And I think everyone knows about this galaxy. And this is also called as M31, which is its catalog number. And there are spiral arms in this particular galaxy as well. This is a spiral galaxy. And if you think about the distance to this particular galaxy is 2 million light years away, right? So which means even if somebody travel at the speed of light, it will take around 2 million years to travel here, right? For the nearest, one of the nearest large galaxies, right? Now you can see that from the current technologies that we have, it seems impossible, right? For us to do this during our lifetime. So this is why powerful telescopes are important, so that we can observe things from Earth, right? And if you think about this M31 Andromeda galaxy and our Milky Way, and also these small galaxies that I showed you in the previous slide, all these galaxies are actually, again, a small galaxy cluster, or a small cluster, which consists of around 50 galaxies. And this particular cluster is called as the local group. Now you can see that first we have our own Earth, and then the Moon, and then we have the solar system as a group. And after that, we have our own Milky Way, which consists of large number of stars and star clusters. And that looks like one unit. And when you go outside the Milky Way, we have this Small Magellanic Cloud and the Large Magellanic Cloud and this Andromeda galaxy, galaxies like that, right? So when all these galaxies are taken together, around 50 galaxies are there. When all these galaxies are taken together, we call that as the local group of galaxies. So which is a galaxy cluster now, right? So previously we have star clusters inside galaxy, in our own galaxy. Now we have galaxy clusters, which means the collection of galaxies, right? So that's how these units are made of in astronomy. And when you actually go into this side, we used to tell that we are going into the cosmological scale now, like larger scales, Right. Now, let's see whether there are other units that are larger than this. Now, the image that you see here is a part of cluster of galaxies. Now, the the group which we called as a local group is actually consists of around 50 galaxies, which is a relatively smaller one compared to large galaxy clusters. Now, what you see here in the image in the left-hand side is actually a cluster of galaxies located about 60 million light years away in the constellation Fornax. So there is a constellation called Fornax, and this particular galaxy cluster is very close to that particular constellation. The constellation means the star constellations, like, right? So we will talk about that in the next lecture as well. And now all these objects, I don't know whether when I am pointing the mouse, whether you can see it or not, but all these fuzzy objects, one right here, one right here, right here, all these objects are actually galaxies, right? Single galaxies that represent here. And you can identify this one, which is on the lower right-hand corner very clearly, because you can see the spiral arms, right? But all these other extended fuzzy objects are galaxies, right? So you can see large number of galaxies here, which is just a part of this galaxy cluster, right? So this is just a part of this Fornax galaxy cluster. And so you can see that we have the local group, and then when you go into these different scales, we have large galaxy clusters that consist of, maybe 1,000 galaxies, 2,000 galaxies, maybe even number of galaxies, maybe even more than that. So these are called galaxy clusters, right? Now, if you go into the next level, now we have these galaxy clusters. Now, if you think about our local group, which consists of 50 galaxies, it is actually a part of a supercluster of galaxies. Now, this supercluster is called as Virgo cluster. So the supercluster means collection of galaxy clusters. So you have galaxies, and then you have collection of galaxies as galaxy clusters, and then you have a collection of galaxy clusters. So that is called a supercluster, right? Now, when you think about a supercluster, for example, this Virgo supercluster where we belongs, so basically we are inside the local group, and the local group belongs to the Virgo supercluster. The size of this Virgo supercluster, or the distance or the size, is around 110 million light years. You can see the size of these units, right, in astronomy. Right. Now, if you think about even beyond that, after these superclusters and clusters, when you go into very large distances, right? So because there is a limit now, so you can look at these distance galaxies, and when you go into these, let's say for around 8 to 9 billion light years away, not million light years. If you go into the scale of the billions of light years away, it is even harder to detect these galaxies, right? So what we can see in these larger scales is this object called quasars, right? Actually, the quasars are actually the centers of galaxies, which has very special properties. And you probably have heard that there is always a black hole at the center of a galaxy, and these quasars are kind of related to the black holes as well. And so these quasars you can detect because of their enormous brightness. Even they are so far away, they are very bright, so that you can detect those. And we have actually detected quasars around 10 billion light years away, right? So that is the advantage of that is why quasars are kind of popular among astronomers. And actually, when you go into this particular scale, like when you need to look at 10 billion light years away from here, you need to have large telescopes, and very sophisticated light amplifying devices. So that means like cameras, like CCD, like high-end CCD cameras, and then a lot of labor work to build these telescopes, right? Now, when you go outside and in every clear night, even though you don't know, there are large observatories around the world that astronomers and students like you who initiated, who start learning about astronomy, are actually working in these large observatories by and they are looking for solving these different mysteries in the universe, right? Using these large telescopes, right? And so so this is what astronomy is all about, right? Right, solving these different mysteries in the universe. And so I personally have this experience where I have been observing these galaxy clusters and looking at something called star formation inside these galaxy clusters in around 2015, 16, and 17 using a very large telescope in Tucson, Arizona in USA. So that was my personal experience, which is actually very one of the great experience that one could get, right? So if the time gets at the end, I used to explain some of my research work to students as well. But you know, we have a very limited time that I have to teach you a kind of important things here. So I'm not going to go into too much details about that. But if anybody is interested, you can feel free to ask anything about those. Right. Now, if you now I told you that we started from our own Earth and move on to the moon, and then sun, solar system, stars, double stars, triple stars, star clusters, galaxies, and then galaxy groups, and then galaxy clusters, and then into the superclusters. And we talked about the quasars, which are the objects that are most far away for us, right? Now, the other question is, now we are looking at far and far away, and we can still see these objects, right? So for example, when you look at the quasar, let's say 10 billion light years away right now. So what that means is you are looking at an object that was there 10 billion light years away. And we don't even know whether that object is right there right now, right? Because the light has to travel from that particular objects to us. So it takes 10 billion light years, right? So what we know is how that object looks like 10 billion years ago. Basically, we are looking at the past or looking at the history. So that's how astronomy works. Now, the question you should have is when this universe started then, right? Because when you are looking at 10 billion light years away, still there is an object. Something is there, right? So let's say look at 11 billion light years away and maybe 12 billion light years away, whether we have objects still, right? So this particular cosmic calendar will give you an idea where the universe started and how it has evolved up to how it looks like right now, right? So just to give you a brief idea, so we will talk about the Big Bang theory at the end of this particular lecture series, which is the theory or currently accepted theory that we believe how the universe started, right? From a huge explosion, everything started, and there were like a very fundamental, these subatomic particles initially, like quarks, leptons, those kind of stuff. And then the atoms created, like electrons, protons, neutrons created. And then from those, the hydrogen is the first element that is created. And like that, it grew up like that. And then you have the stars and then galaxies. So that's how it continued like that, right? If you look at this particular calendar, cosmic calendar, if you shrink everything to a calendar, you can kind of make an analogy how it looks like. So in January, the Big Bang happens, and February, then there is this image, and then when it comes to the March, you have some stars, and then, you know, galaxies born around May, and then you have galaxy clusters right here, and then the planets formed around August and September, and like that. So the Earth's atmosphere become oxygenate around October, and then in November you have first complex life form. So you can see how long it has taken for life to exist, right? And then if you look at the December calendar a little bit, you know, separately, we can see that land plants appear around December 20th, and then the dinosaurs appear December 25th, and mammals appear December 26th, and then December 30th, dinosaurs become extinct, right? And then humans appear December 31st. So what I try to tell from here is the life began, if you compare the whole cosmic scale or the time, we have lived, humans have lived in the universe for a very short period of time still, right? So it's just December 31st, right? If you look at the whole time period. So remember that this is just an analogy that is made by all these events compressed into a calendar, right? Just to give you an idea how it has worked and how it looks like, right? Right. Now that will end up my basic introduction, and there will be a small video to show you. So let me see. And I assume that all of you can see my screen, but maybe not with the sound, but I have actually shared this slide. So you should be able to watch this video, and I assume that all of you can see my screen, right? So I will briefly just go through the video and just explain what kind of things this particular video tells you. It basically gives you an idea about the scale of the universe, this kind of summarizing what I have explained up to now, right? So this is our own Earth, starting from the Tibet. And it's when you scale, you know, when you zooming it out, you can see the whole, the shape of our own universe in a spherical shape. And this is the planet Earth, right? By the way, I am not sure whether you can see why I'm sharing a video. If you cannot see it, please let me know, right? So I assume that all of you can see it. And so this is our own Earth. And if you look at the Earth, there are a lot of, you know, artificial satellites now around the Earth. So this is how it looks like. But when you go into the next level of scale, you will see our Earth is actually very small in the universe. And you can see the sun on the left-hand side. And when you go into the next scale, so like this is like 1 second travel from light, and you can see the moon's orbit. And here is the orbits of the planets when you go into the next scale. Now you can see Earth is just one planet in this solar system, right? So you can see the place that we have in this universe is very, very tiny. So that's what I need to show you. And these constellations that we have is the next one, which is again outside the solar system. So when you look at the constellations, you cannot even figure out our own solar system, right? You can see that it's very tiny. Now it's now you will see that the next level will be our own galaxy, Milky Way, and you can see we are in a very tiny age inside this Milky Way, and the Milky Way is also becoming smaller, and then all these dots represent the galaxies that are nearby. And these are all the galaxies that are actually mapped so far from large galaxy surveys. And this is how it looks like, right? So these empty areas are the areas that we do not have data yet to map. And you have the afterglow from the Big Bang, which is around 13.7 billion light years ago. And you will learn some of these things by, step by step when we go into the lectures. And if we come back to present again, so that's what we are doing here from this large scale, we are come back again to the present day. And you will see that we go through the galaxy clusters, and then we will come back to our own galaxy. And inside the galaxy, we are in a certain place, in a very tiny place where we have our own solar system right here. Right, so still we are going through this journey to our solar system, and this is our solar system. And once you zoom into it, we have the different planets. And inside these planets we have, here we go, here is our planet, right? And inside the planet, we are just in a particular location. So if you zoom into the location that we live in, now this is zoomed into a different location, but if we zoom into our country, let's say for the Sri Lanka, we are in a very tiny place in the universe, right? So we don't have, any recognition at least inside this large universe. Just go through this video and look at it, so you will understand what I have explained throughout this particular lecture. And so I'm going to finish the lecture from here today. And on the next day, we are going to look at the night sky, right? So I hope that from these first two lectures, you probably have a good idea about what kind of universe that we live and what is the scale of that universe and why we use this light years as a unit, those kind of things, right? So the basic understanding. And what we will do from the next day is, for the first few lectures, on the next day, I will introduce you the different, the night sky, how the night sky looks like, and like different coordinate systems and different, let's say, definitions that we use to look at the night sky. It's kind of a practical lesson, and also a little bit history about the astronomy. That will be probably the next 1 or 2 lectures. And then I will go into the section about explaining a little bit of physics behind the motion of these astronomical bodies, how you use Newton's laws and then Kepler's laws to explain the motion of these planets and everything. And then little by little, we will move on to these different scales. We will talk about the planets, sun, and then the stars, evolution of the stars, and after that these large objects like galaxies, galaxy clusters, and then move into the Big Bang, right? That means the cosmological part. So that's what we will be doing throughout this lecture. So probably this video and this particular introductory presentation will consist like a summary of what we will be going through in the next set of lectures, right? Everything that we explain will fall into one of these sections. So what we will do is we will take different parts, and for example, planets, and then when we talk about the stars, we are going to like star clusters, how stars evolve, what kind of things that we can measure inside the stars, those kind of things, right? Like that. Then we will talk about the galaxies, the parts of the galaxies, why they are important, what kind of things that we have inside galaxies, those kind of things, right? Right, so it's 10 p.m. now, so I'm going to stop the lecture for today. Anybody have any questions up to here? Please feel free to ask. Right, so if you do not have questions, and I am sure there may be other students who have not joined, right? So please pass the message that we are doing this interactively, not just the recorded lecture. Because of that, make sure that you join, because from the next day on, I will most probably share the slides in this way for you, and you will have to answer the questions based on what I am teaching you, right? or what we are discussing in the class, right? So in that way, we will it will be easier for you at the end. So you will know what you have learned at the end, right? Right. Thank you, and good night to everyone who joined. And let me. So we will meet again on this Wednesday at the same time, right, for the third lecture. Right. Thank you so much, and good night to everyone.